assessment asks us to predict a reasonable chemical shift value for the carbon NMR signal for each of the carbons in this molecule. Going ahead and label the carbons, let's figure out their chemical shift. All three of these methyl groups are equivalent to each other, so they're all represented by the same signal, and they are all alkyl type carbons, and so they would have a chemical shift of approximately 20 ppm. Is it going to be exactly 20? No, we're just picking an average value in the range for an alkyl proton or alkyl carbon. Carbon B is also going to be in the same chemical shift range. It's also going to have a carbon chemical shift of around 20 ppm. Actually, the same is true for E and F, so we can go ahead and add those in here as well. Those are also alkyl type carbons, and so those will also have chemical shifts of approximately 20 ppm. Again, they're not all going to have a chemical shift of 20. They're going to be in that range around 20 because they're all alkyl type carbons. Carbons C and D are part of the alkyne, so they'll have a chemical shift of around 90 parts per million or so. That leaves carbon G. Carbon G is part of the carbonyl, so it will have a chemical shift of approximately 210 parts per million, give or take. Will it be exactly 210? No, probably not, but it will be close to 210 in that region. These are the approximate chemical shifts for the carbon NMR signals for this particular structure.